So for figure P 4.12, we have a beam. Again, beam we supported by a pin at A and a roller at C. And also it has a couple at B of 12 kilonewton meter and a distributed load of 8 kilonewton per meter. A total distance of 8 meters. The distance from A to B is 5 meters and B to C is 3 meters. So it is a distributed load of 8 kilonewton meters. So what we will multiply it by 5 meter so that we will get a 40 kilonewtons at the center. So 40 kilonewtons at the center. So summation of moment at C is equal to 0, taking counterclock positive. So counterclock RA times 8, so that is negative RA times 8 plus 40. This is a counterclockwise, so 40 times 2.5 plus 3, that is 5.5. So I divided this distance so that I can get the moment for 40 kilonewtons to see. So plus the couple of 12 kilonewton meter, this is 12. Then I'm getting the values for reaction at A. Reaction A is equals to 40 times 5.5 plus 12 divided by 8. It will gives us a 29 kilonewton. Summation of forces at Y taking up positive is equals to 0. Therefore, RA positive minus 40 kilonewton plus RC is equals to 0. Therefore, RC is equals to negative 29 plus 40. Therefore, RC is 11 kilonewton. So we will cut the section segment AB and BC. For segment AB, where x is greater than 0 and less than 5. So this is the cutted section. The distance of the cutted section is x. Then we have a distributed load 8 kilonewton meter per meter, so that the distance, the middle distance will be divided by 1/2. So x times 1/2, it will be x over 2. Then the shear force of V is downward, that is positive, and a moment of counterclockwise. So summation of moment at D is equals to 0, taking counterclockwise positive. Therefore, it's M, so this is positive M minus 29 times your x plus 8 kilonewton meters times x over 2. So that is counterclockwise, that is positive. Therefore, your M is equals to 29x, transpose the other terms to the other side. So that is M is equals to positive 29x minus 8 divided by 2, that is 4. Then x times x, that will be x squared. So that your moment, the bending moment is equals to 29x minus 4x squared. Summation of forces at y is equals to 0. So taking up positive, so that is 29 kilonewton up minus 8x, that is 8x downward, 8x minus v, so that your v is equals to, transpose this the other side, transpose with the other side, so that will be positive. So v is equals to 29 minus 8x. For segment BC, where x is less than 3, less than 5, greater than 5 but less than 8. So this is the cutting section. We have roller here at C, a reaction at C of 11 kilonewton. Though the distance of this scattered section is 8 minus x, so this is 8, 5 meters plus 3 meters, so there's 8 minus x, that this will be the distance of your scattered section. And then we have a shear force of V up, taking up positive, and a moment of bending moment of clockwise, that it will be positive. If the segment is cut on the left side, this point F. So summation of moment at F is equal to 0, taking clockwise positive, where your M is positive, M minus, that is counterclockwise, so minus 11 times your distance, 11 times 8 minus x, that is equals to 0. Then transpose the other side, so M is equals to 11 times 8 minus x. Therefore, the bending moment is equals to 88 minus 11x. Summation of forces at y is equal to 0, taking up positive, that is V. So this is V up positive. V plus 11 kilonewtons is equals to 0. Then V is equals to negative 11 kilonewtons. So this is the diagram for the bending and shear, for the shear and moment. So for shear force, the segment AB has a where your x is greater than 0 and less than 5. So the first shear force, that is 29 minus 8x, substitute x to 0, so that 29 minus 8 times 0, that will gives you 29 kilonewtons. So this is 29 kilonewtons. And substitute the x to 5, that is 29 minus 8 times 5, that is negative 40. So 29 minus 40, that is 11 kilonewtons. So this is 11 kilonewtons. The line will move diagonal up to negative 11, where your segment BC, taking x is greater than 5 but less than 8, where your shear force is negative 11 kilonewtons. Also in the bending moment at segment AB, where your x is greater than 0 and less than 5, the bending moment of M is equals to 29x minus 4x squared. So substituting x is equal to 0, so 29 times 0 minus 4 times 0 squared, that is also 0. Then substitute the x is to 5, so 29 times 5, that is 145, minus 4 times 5 squared, so 5 squared is 25, times 4, that's negative 100, times negative 4, that is negative 100. So 145 minus 100 is 45 kilonewton meters. So this is 45 kilonewton meters. If the graph of the shear force is what do you call this? The graph of shear force is in a slope. Yeah, in a slope, then the bending moment will curve. That is 45. Then, so at segment BC, where x is less than 5, greater than 5 but less than 8, then bending moment is equals to 88 minus 11x. Substituting x to 5, that is 88 minus 11 times 5. So 88 11 times 5, that is negative 11 times 5, that is negative 55. Then 88 minus 55, that is 33 kilonewton meters. It will drop here to 33 kilonewton meters. Also, substituting x is equals to 8, where 88 minus 11 times 8, 11 times 8 is equals to 88. So 88 minus 88, that is 0. It will jump here at 0. So we will find the maximum bending moment the maximum bending moment is 45 kilonewton meter. It's 45 kilonewton meter. Also, for the maximum shear force, maximum shear force is 29 kilonewton. So this is the maximum shear force and the maximum bending moment. So thank you.